Okay, Puta. Last week we have discussed about dimensions of a derived physical quantity. We have briefed how to determine the dimension of a the dimension of a derived physical quantity. I think we have done some examples, no? Then today we are going to study it. Okay. First, as example, if we want to determine the dimension of a derived physical quantity, the first thing we have to do is write an equation. Defining that derived physical quantity. As example, if we want to find the dimension of velocity, you have to write an equation for velocity with basic physical quantities. You know, velocity is equal displacement over time. So the dimension of velocity, first we have to write the equation. For derived physical quantity with basic physical quantities. Okay, that is the first step. After that, we can assign dimension of basic physical quantities here. Okay, then we can determine the dimensions of derived physical quantity. Okay, as example, if we want to derive the dimension of velocity, first we have to write an equation defining the velocity. Okay, in this case, velocity is equal to displacement over time. So the dimension of velocity is equal to the dimension of displacement over dimension of time. Okay, we have defined the dimension. Displacement is a length. So we have defined the dimension of three main basic physical quantities, that are length, time, and mass. So we have to assign those physical quantities in this equation. Okay, in this case, the dimension of displacement is a time, so dimension of displacement is L. Then dimension of time is T. Okay, then the dimension of velocity is equal L. You have to bring this T to the numerator, so then it will be -1. L T -1. So dimension of velocity is LT -1. That is the way of deriving the dimension of derived physical quantities. Okay, the first step one is we have to write the equation for the particular derived physical quantity. That is the first step. After that we have to assign the dimension of basic physical quantities in that equation. Then we can determine the dimension of derived physical quantities. Okay. Okay. Let's do some examples. Okay. I think up to this we have discussed in our last class. Okay. Okay. Shall we do some examples?
So do you have to write this down?
Sorry?
Do we have to write this? Do we have to write this?
This on
the board, yeah.
I think we already written this one, no?
Also, last week I couldn't come. That's why.
Sorry?
I guess I. last week I couldn't count that, sir.
Okay puta. Okay. Do you follow the recording?
No, there was no recording. You said
No,
it,
class number
your
3.
crowd
Class
is
number
already
3. There was recording.
class. Yeah, was there? Okay, I'll check it out. I guess.
Okay,
after
okay,
this
okay.
class.
Class number 3, there's a recording. The class number 2 is the missing one. I will send that within tomorrow. Okay, today not possible. Within tomorrow, I will send that one. Okay, that is class number 2. That is the missing one. Class number 3 is there. Okay. I think this example we already wrote this example. Okay, shall we do some another examples in this tute? Okay, I will do first 4 examples with you. First 4 examples. Okay. First 4 examples. Determine the dimension of the following physical quantities. First one is volume. First one is volume. Dimension of volume is equal. Volume is equal length into length into length. First we have to write that equation. Write that equation. Length into length into length. So, dimension of, look at this. Volume is equal to length into length into length. First, we have to write this equation. So, the volume, the length, dimension of volume is equal the dimension of length into dimension of length into dimension of length. That is L into L into L. So, it is equal L cube. L to the power 3. Dimension of volume. Second one. Second one. Second one, we already done velocity. Third one, acceleration. Acceleration. Okay, I will do second one too. Velocity. Velocity. Then third one, acceleration. Fourth one, force. Fifth one, pressure. Okay, Buddha. Let's do this. Velocity. In our first example, we have discussed this one. Velocity is equal to displacement over time. This is our equation. So, then we can apply the dimensions. The dimension of velocity is equal to the dimension of displacement over dimension of time. Dimension of displacement. Displacement is a length, so dimension of displacement is equal to L. Dimension of time is T, so this one is equal to LT minus 1. LT minus 1. Acceleration. Acceleration is equal to velocity over time. Velocity over time. It is equal to velocity over time. So, this is our first step. Write in the equation. Write in the equation. That is our first step. Then we have to apply the dimensions. dimension of acceleration, so equal to dimension of velocity of dimension of time. You have determined the dimensions of velocity, that is equal to LT minus 1. You can apply that one. LT minus 1 over T. Then you have to bring this denominator to the numerators. Then it will become minus 1. That means LT minus 2. LT minus 2. So dimension of acceleration equal LT minus 2. Then force. We can write an equation for force. Force is equal mass into acceleration. If equal ma, mass into acceleration. Then we can apply the dimensions. The dimension of force is equal to the dimension of mass into dimension of acceleration. Dimension of mass. We know the dimension of mass. We have defined that one. Dimension of mass is equal to m, capital M. And dimension of acceleration is equal to, we have found this out, LT minus 2. So this is equal MLT minus 2, very important dimension. MLT minus 2. Pressure. How to define a pressure? Pressure is equal to force over area. Force over area. So dimension of pressure, then we can apply dimension, Puta. Dimension of pressure is equal dimension of force over dimension of area. Dimension of force over dimension of area. Area means length into length. We can write this one, no? Length into length. Now we can apply dimensions. Force means MLT minus 2. Over L into L. So this cell will be cancelled out with this cell. Then this cell can be brought to numerator. Then M, this is plus L plus 1. It will become minus 1. Minus L minus 1. T minus 2. So M, L to the power minus 1. T to the power minus 2. Okay. Do you understand how I determine this one? Do you understand?
Yes, sir.
No, Pada. This tube is not a separate tube because I need to do all of these questions in your notebook. Okay. Therefore, you should do these questions in your notebook. That is a part of the note. Okay. Everyone, do you understand this one, or shall I explain again? Do you understand this one? If you understand this one, please give me a thumb. Good. Very good. Okay. Write this one. Okay. Order means puta. That is a very good question. That is a very good question. Actually, normally, this is not a rule. This is not a rule, but it is a thumb rule. Thumb rule means it is a we can use this one as a regular pattern. Normally, when we are writing a dimension, we are writing the least power to the right hand corner, and the highest power to the left hand corner. Okay, that is not a rule. Okay, if you or interchange these terms, it will be not a wrong answer. Okay, but for a pattern, normally we are writing the highest power to the left corner and the lowest power to the right corner. Okay. Okay. Once you finish that, then this one, please let me know. Once you finish writing, please let me know. Good. Okay. First 5 questions. We have done now first 5 questions. Okay. Shall we do up to 15? No? Up to 15. Shall we do up to 15? Now you have to do 10 more questions. You have to do 10 more questions. 10 more questions. Up to 15. Up to 15. Now I have shared my screen. There are 15 questions up to 5. We have done up to 5. So you have to do question number 6 to question number 15. I will give 10 minutes. Okay. I will give 10 minutes. Okay. Once you uh, complete the questions up to 15, please let me know. Okay. Yes. Yes, definitely there will be a question. There will be a question in exam, but these are very simple questions. In the exam, we have to do dimension analysis part. That will be actually it will be a not a difficult one, but difficult relative to this. We are going to study dimension analysis in this class. Okay. Okay. Once you complete up to 15, please let me know. Okay. පුතා there is a question number 13, Young's modulus is stress over strain. But I think you don't know about this strain. Okay, please do question number 22 before that 22. In question number 22, strain is defined. Strain is defined. Question number 22. Okay. Okay, everyone, have you complete this one up to 15 and 22? තාම කරනවද නැත්නම් කරලා ඉවරද? Once you complete the up to 15, please give me a thumb or yes. Okay, then I can identify. Good. Others? Good. Others? Good. Very good. Okay. Shall we discuss? Okay. Density. Density. What is your answers? What is your answers? You can unmute and give me your answers. What is the answers for density? The dimension of density. The dimension of density is equal dimension of M over dimension of P. So what is the answer for dimension of density, Buddha? Dimension of density. Huh? Anyone? Dimension of density?
ml minus 3.
ml minus 3. Very good. M over density. The dimension of M. Dimension of M is equal to capital M. Dimension of volume is equal to L cube. L cube, L to the power 3. So this is equal ml minus 3. ml minus 3. Energy. Both are same. Energy and work done. Both are same. F into displacement. So the dimension of energy or dimension of work done, dimension of energy or dimension of work done is equal to dimension of force into dimension of displacement. So what is the dimension of energy? Dimension of energy is equal to dimension of energy is equal to Oh, answers then.
FL.
Sorry?
FL.
Not FL, Puta. F. There is a dimension for F. There is a dimension for F2. What is the dimension of F? You have to assign dimension of F2. MLT minus 2. MLT minus 2. The dimension of F. Dimension of F is MLT minus 2. Then into D. D means displacement. Displacement means it is a length. So dimension of D is equal to L. L. Now MLT minus 2 into L. MLT minus 2 into L, Puta. That's mean M L is squared. M L is squared T minus 2. ML is squared T minus 2. Make avada? Do you understand now? Do you understand now? Good. Then momentum. Momentum is M into V. M means mass. V means velocity. So dimension of momentum is equal to the dimension of mass into dimension of velocity. Dimension of mass into dimension of velocity. Okay. Dimension of mass, you know that one. That is equal to m. That is equal to m. And we have determined the dimension of v. Dimension of v. That thing we can use here. Okay. What is the dimension of v, Puta? Velocity. What is the dimension of velocity? Lt minus 1. Lt minus 1. So the dimension of momentum is equal mlt minus 1. mlt minus 1. Do you understand, Puta? Everyone, if you have any question, if you have any doubt, please let me know now. Okay. Because after these lessons, we have to go to dimension analysis part. Dimension analysis part, that is very interesting part, and that is the core part of this lesson. Okay. First, we have to understand this one. Sorry, we have to understand this one very well. Then only we can go to the dimension analysis part. Okay. So if you have any question or any doubt, please let me know now. Okay. Okay. What is the answer for question number 10? Dimension of power. Please let me know now. Dimension of power. Dimension of power.
ml squared t minus 3.
Sorry?
ml squared t minus 3.
Yeah. Okay. So dimension of power means dimension of work. Dimension of work. Dimension of work done over dimension of time. Dimension of work done over dimension of time, Puta. Dimension of work done. Work. We have found this one here, no? That is equal to ml squared t minus 2. Dimension of work done. ml squared t minus 2 over time, over t. So this is equal to ml squared. Here t, we can bring that t to denominator, then numerator, then t minus 3. T minus 3. Okay. Do you understand this one? If you understand this one, please let me know. Please give me a thumb. Please give me a thumb. Okay, very good, very good, very good, very good. Okay. Then dimension of potential kinetic energy, that is equal dimension of energy and dimension of potential energy. Dimension of kinetic energy. Kinetic energy is an energy. Potential energy is an energy. So the dimension of kinetic energy equal to the dimension of potential energy, and both are equal to the dimension of energy. We have found this one, dimension of energy, that is equal to ml squared t minus 2. ml squared t minus 2. So this is equal to ml squared t minus 2. ml squared t minus 2. Then stress. Stress is equal force over area. Actually, stress is another physical quantity, but that is equal to pressure. I think you know the equation for pressure. You know the equation for pressure, Puta. Pressure is equal to F over A, force over area. Pressure is equal to force over area. That thing you already know. Okay. Stress. Stress is another physical quantity, but it is equal to pressure. It is equal to pressure. Okay. Stress is equal to F over A. F over A means force over area. Force over area. Okay, Putta. Very good question. That is very good question. In kinetic energy, there is a half, no? Half mv square. Half mv square. What's about half? Then half. Half mean, Putta, it is a numerical value. It is a numerical value. It is a number. It is not a physical quantity. No. Half is a number. Okay. Half is a number. It is not a physical quantity. Okay. It is not a physical quantity. Half mean it is a number. Okay. Okay, we can write this one. Okay. Kinetic energy. Kinetic energy. Kinetic energy is equal to half mv squared. Half mv squared. So, if you want to determine the dimension of kinetic energy, we can apply this one. Half. Half is a number, Buddha. Half is only a number. Half is only a number. So, it doesn't have a dimension. Half doesn't have a dimension. Okay, it is just a number. Dimensions. Dimension means it is a relationship between a derived physical quantity and basic physical quantity. So half is not a physical quantity, no. So half doesn't have a dimension. So dimension of kinetic energy is equal to the dimension of m into dimension of v squared. You can write this one also. Okay. Okay, I will show that now. Dimension of kinetic energy is equal dimension of m into dimension of v is squared, Putta. Shall we simplify this one? Dimension of dimension of m is equal to m. Dimension of v is equal to L t minus 1. We have to take its square. We have to take it square. Then what will happen? We can simplify this one. M L is squared. No, L to the power 2. L to the power 2 means L is squared. L is squared. Then t minus 1 there. T minus 1 into 2. That means t minus 2. T minus 2. Yes. If there is a numerical value, we don't want to consider that one. Okay, we can neglect that one. Okay, because this is just a numerical value. This is just a numerical value. Okay. Okay. Dimension is the relationship between a derived physical quantity and basic physical quantities. Dimension of a derived physical quantity is a relationship between that particular derived physical quantity and basic physical quantities. So half is not a physical quantity, it's just a number. So it doesn't have a dimension. That's why the dimension of potential energy is equal dimension of m into dimension of v squared. Okay. Okay. Then we can get the dimension of potential energy too. Potential energy. Shall we do that? The dimension of potential energy. Dimension of potential energy. Dimension of potential energy. Potential energy is equal, I think you know that equation. What is that equation? Potential energy? What is the equation for potential energy? mgh. Very good. mgh puta. So dimension of potential energy is equal dimension of m into dimension of g into dimension of h. Dimension of h. Okay. Dimension of potential energy is equal dimension of m g h. Okay. Dimension of m. Dimension of m. M is mass, puta. M is mass. Dimension of m is equal to m. M. What about g? Dimension of g? Can anyone tell me? Dimension of g. Can anyone tell me? Dimension of g is equal to?
LT minus 2.
Sorry?
LT minus 2.
LT minus 2. Very good. Because g is a gravitational acceleration. Gravitational acceleration. It is an acceleration, puta. It is an acceleration. So we know the dimension of acceleration, that is equal to LT minus 2. So this is equal to LT minus 2. Dimension of g. Then dimension of h. Dimension of h means it is a height. It is a height. Height is measured by a length. So dimension of height is equal to L. MLT minus 2 into L. We can simplify this one now. M, there are two L's. There are two L's. That means L is squared. L is squared. And T to the power minus 2. T to the power minus 2. Okay. You should write both, okay? Potential energy and kinetic energy. Now, do you understand this one? Both the? Do you understand both calculations? Okay, very good. Very good. Okay, Buddha. Now we can go to the question number 30, no? No, 12. 12th one. 12th one means stress. 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 Stress is equal force over area. Force over area. 12th one. Okay. So the dimension of stress. Dimension of stress equal to dimension of F over dimension of A. Dimension of F over dimension of A. Okay. Dimension of F. F means force. Dimension of F. Dimension of F means dimension of force. Dimension of force is equal M L T minus 2 puta over dimension of area. Dimension of area is equal L square. So this is equal M dash L to the power 1, that's L to the power 1, and denominator, that is L to the power 2. Then 1L will be cancelled out. Then ml minus 1 t minus 2. ml minus 1 t minus 2. Did you get this answer? Did you get this answer? Good, very good, very good, very good. Very good. Then I have told you, first you should do question number 22. It is about strain. After that, you can go to question number 13. First, you should do question number 22. It is about strain. Sorry, strain. Strain is equal to elongated length over the original length. Okay, I will explain this one to you. Suppose there's a rod or some material. Suppose there's a rod, very small rod or wire. Suppose there's a wire. Okay. Once I apply a force into downward direction, on this wire, the length of wire can be changed or can be increased. Okay, the length of wire can be increased due to that force. Due to this force, the length of wire can be increased. Okay, this change in length is called as the elongated length. Normally we call as simple E. This is called as the elongated length. Okay, and we know this one, this length is the original length, Puta. This is the original length. This is the original length. Original length is L. Once I apply a force, this wire has been elongated up to this level. So the elongated length is this much. Okay. The strain is equal to the ratio between elongated length and original length. So the strain is equal to elongated length over the original length. Okay, that is the physical quantity represented by strain. Do you understand this one? Okay, strain is equal to the elongated length over original length. So the dimension of strain is equal to the elongated length over original length. Elongated length is a length, Puta. It is a length. Okay, so dimension of a length is equal to L, capital L. This is equal to capital L, and original length, that is also a length. So we have to replace this by L over L means that is equal to 1. That is equal to 1. 1 means strain does not have a dimension. Okay, if the dimension of a particular physical quantity is equal to 1, that means that physical quantity does not have a dimension. Okay, then because it is a ratio between length over length. Length over length means definitely it will not have a dimension. Okay, length to length will be cancelled out. So strain does not have a dimension. Strain does not have a dimension. So we can write the dimension of strain is equal to 1. Dimension of strain is equal to 1. That means strain does not have a dimension. We can write this one. So strain doesn't have a dimension. Strain doesn't have a dimension, Putta. Do you understand this one? Very important one. Very important one. Okay. Then you can do question number 13. Question number 13. Young's modulus, no? Young's modulus. Question number 13. Dimension of Young's modulus. It is equal to dimension of stress over dimension of strain. Young's modulus is equal to stress over strain. Stress over strain. So dimension of Young's modulus is equal to dimension of stress over dimension of strain, Putta. Now you have to apply dimension of stress and dimension of strain here and get the dimension of Young's modulus. What is the answer? ml minus 1 t minus 2. Very good. Others? Okay. Dimension of stress. You know the dimension of stress. That is equal to ml minus 1 t minus 2. ml minus 1 t minus 2 over dimension of strain. Dimension of strain. Dimension of strain. It doesn't have a dimension. So we cannot try this under this one. It doesn't have a dimension. Okay, we cannot do that. If it is this, if any physical quantity does not have a dimension, we can equal its dimension to 1. Okay, if any physical quantity does not have a dimension, we can equal its dimension to 1, Putta. Okay. So when we are calculating, when we are doing calculation, when we are simplifying an equation, we cannot write it doesn't have a dimension. Okay. So if any physical quantity does not have a dimension, when we are calculating, we can write it dimension as 1. Okay. So strain, we know, now we know strain does not have a dimension. So its dimension is equal to 1. Its dimension is equal to 1. Okay. MLT over 1 means it is equal to MLT. It is equal to ML minus T minus 2. ML minus 1 T minus 2. Do you understand this one? Do you understand? Everyone? If you understood, please let me know. Please give me a thumb. Or if you have any questions, please let me know. මොකටද තේරුණාද? Very good. Good. Okay. Question number 13. Then, question number 14 is spin constant. Is spin constant. Is spin constant. The spin constant is equal to F over D. F means force, D means displacement. I will explain that too. I will explain that about that physical quantity. Shall I erase this one? Okay. The spring constant. Suppose there is a spring. There is a spring. Suppose there is a spring. And we have applied a force which is equal to capital F on this spring. We have applied a force. Once we apply a force to downward direction, the length of this spring will be increased. That means it will be elongated. If it is elongated up to distance D, under a force which is equal to capital F, the spring constant of this spring is defined the ratio between F and D. Okay, that is the physical quantity which is represented by is a spring constant. Okay, so a spring constant is equal to F over D. Okay, you will learn this one. Okay, you will learn this one, but until then you have to get some basic understanding what is this about. So the spring constant is equal to F over D. F means the force applied, D means the displacement or elongation under this force. Okay, so a spring balance, so a spring constant, so is this dimension of a spring constant is equal to the dimension of F over dimension of D, dimension of F over dimension of D. So dimension of F means it is a force. Dimension of F is equal MLT minus 2, and dimension of D means D is a displacement, that is a length, Puta. That is a length. So it is a length. Then L to L will be cancelled out. Then the dimension of the spring constant is equal mt minus 2, mt minus 2. Did you get this answer? Did you get the answer? Okay. $15. Impulse. Impulse. What is the answer for impulse? Impulse. Impulse. What is the answer for impulse? Dimension of impulse?
MLT.
MLT minus 1. Eh? Impulse. Dimension of impulse is equal to dimension of force into dimension of T puta. Dimension of force into dimension of T. Dimension of force, we know the dimension of force, that is equal to M L T minus 2 into T. Into T. There's minus 2 and there's plus 1. Plus 1 minus 2 means minus 1. Minus 1. So M L T minus 1. M L T minus 1. Okay. Do you understand? Very good. Good, good. Okay. Okay. Then we should go to the next questions. Okay. Question number 16 to 21. 16 to 21. Question number 16 to 21. Shall we do question number 16 first? Shall we do question number 16 first? Then we can go up to 21. First, you should do question number 16, then we can discuss that one. Then 17 to 21, you should do with you alone. Dimension of the angle. Dimension of the angle. Dimension of the angle. What is the dimension of the angle? Anyone? Tell me, what is the dimension of angle? Dimension of angle.
No dimension.
Sorry?
No dimension.
No dimension. Very good. Dimension of angle. Look at this, Puta. Angle is defined as a ratio between the arc length and the radius. Arc length and the radius. You can remember this equation. S equal r theta. we have done this one. S equal R theta. So if I subject theta, it is equal S over R. It is equal S over R. S means puta arc length, R means radius. Arc length over radius. So angle is equal to arc length over radius. Arc length over radius. Okay. So the dimension of angle is equal to the dimension of arc length over dimension of radius. Arc length means a length, ne? Arc means is a length. So this is equal to L. Radius also a length. Radius also a length, no? So dimension of radius is equal to L2. So L12 will be cancelled out. That is equal to 1. If the dimension is equal to 1, that means this physical quantity does not have a dimension. No dimension. So no dimension. No dimension. Okay. So angle does not have a dimension. Okay. But actually it does have it has a unit. Although it doesn't have a dimension, it has a unit. Okay. Okay. After doing this, you have to do from question number 17 to question number 21. From question number 17 to question number 21. I will give you 5 minutes. I will give you 5 minutes to complete this one. Okay. First, we have to find the dimension for angular velocity. Angular velocity is equal to angular displacement over time. I have to do angular displacement first, okay? Otherwise, someone cannot understand. Angular displacement. Suppose there is an object rotating around circular path, and it has started its rotation from this point. And after some time, it has displaced up to this level. So this is t equals 0, and this is after t second. Okay, it has rotated up to this level. So the angular displacement is the angle it has rotated. That means this angle. So angular displacement is an angle. So you have to note down this one. Angular displacement. Angular displacement is the angle that has rotated. Okay, rotated angle. So angular displacement is equal to a angle. It is a angle. It is a rotated angle. Angular displacement is equal to the rotated angle. So angular displacement is a angle. So the dimension of angular displacement. Okay. So dimension of angular displacement. Dimension of angular displacement is equal to the dimension of rotated angle. Rotated angle is an angle, no? It is an angle. So angular displacement does not have a dimension, or otherwise dimension of angular displacement is equal to 1. We can simply say angular displacement does not have a dimension, no dimension. First, you should do this, okay? First, you should do this. After that, we can continue. Okay. Angular displacement. Angular displacement is the rotated angle. It is rotated angle. So dimension of angular displacement equal to dimension of rotated angle. Angle means angles that do not have dimensions. So angular displacement doesn't have a dimension. Do you understand this one? About angular displacement. Do you understand this one? Very good. Others? Very good. Okay. You can write this one, or you can draw this figure and write about angular displacement. Angular displacement is equal to rotated angle. So the dimension of angular displacement is equal to dimension of rotated angle. Dimension of rotated angle means that is equal to 1. So angular displacement does not have dimension. This is the angular displacement. So we can define angular velocity too. Angular velocity means angular displacement over time. Angular displacement over time. It is very similar to linear displacement and linear velocity. Okay. This is very similar to that. Actually, it is the same definitions. It is the same definition as linear velocity. Okay. We can define linear velocity as the ratio between linear displacement over time. Like as we can define angular velocity between as a ratio between angular displacement and time. Okay. So angular velocity is equal to angular displacement over time. Then we can write the dimension of angular velocity. The dimension of angular velocity is equal to so we can write dimension of angular velocity is equal to dimension of angular displacement over dimension of time. Dimension of time. Dimension of angular displacement, it doesn't have a dimension, so we can write it dimension as 1, and dimension of time is equal to t. So 1 over t means t minus 1. We can bring this t to the numerator. So the dimension of angular velocity is equal to e minus 1. Do you understand this one? Do you understand how I determine this one? If you have any problem, do you understand, Puta? Everyone? Good, good, good. Okay. Then, same as linear acceleration, we can define the angular accelerations too. Angular acceleration too. Angular acceleration is the ratio between angular velocity and the time. Angular velocity and the time. So angular acceleration is equal to angular velocity. Angular velocity over time. Over time. So the dimension of angular acceleration is equal to the dimension of angular velocity over dimension of time. Dimension of time. Dimension of angular velocity. Now I have determined that one as t minus 1 is equal to t minus 1 over t. T minus 1 over t means that is equal to t minus 2. That is equal to t minus 2. We can bring this one to the numerator. Then it will become t minus 2. Okay. Shall I erase this one? Shall I erase this one? Okay. Others? Shall I erase this one? Okay. Then moment of inertia, moment of inertia, moment of inertia. Okay, I will erase this one. Okay, give me the answer. What is the definition of moment of inertia? What is the dimension of moment of inertia? Moment of inertia. Anyone?
ml square
Mass into distance squared.
Mass distance is square. That means
ml square
ml squared. Mass into distance is squared. Distance is squared. So the moment, the dimension of moment of inertia is equal to dimension of mass into dimension of displacement is squared. So this is equal ml squared. ml squared. Angular momentum. Angular momentum. Angular momentum is moment of inertia. Normally we represent it by I. Okay, moment of inertia into. Okay, I will write this one. Moment of inertia into angular velocity. Angular velocity. Okay, so what is the definition? So not a definition. Determination. Dimension of angular momentum. Angular momentum. Anyone? Dimension of angular momentum.
ml square t minus 1
Okay, ml squared. Moment of inertia. Dimension of momentum inertia means ml squared. Puta. Angular velocity t minus 1. ml squared t minus 1. ml squared t minus 1. Then torque. Torque is equal to moment of inertia. That is I, no? I into moment of, sorry, angular acceleration. Torque is equal to moment of inertia into angular acceleration. Angular acceleration. Moment of inertia into angular acceleration. So the dimension of torque is equal. Dimension of torque is equal moment of inertia into angular acceleration. Moment of inertia means ml squared. Angular acceleration means into t minus 2. T minus 2. So torque, the dimension of torque is equal to ml squared t minus 2. Okay, make out. Okay, very good. Very good. Others? Good. Okay. now we have done up to question number 22. Question number 22. That's mean there are another 8 questions. Another 8 questions. You have to leave some space to these 8 questions in home. At home, okay? It is a homework. It is a homework. You have to do from question number 23 to question number 30. Question number 23 to question number 30 as a homework. Okay. හොඳයි. මම අර ටියුට් අප්ලෝඩ් කරන ටියුට් මේ group එකක් හැදුවනේ පුතේ. දැන් අද කරපු මේ questions ටිකයි අද කරපු මේ questions 22 ඒ questions ටිකයි ඊළඟට ඔයගොල්ලෝ homework එකේ කරන ඔය question ටිකයි දාලා ඒකට අප්ලෝඩ් කරන්න මට ඔයගොල්ලෝ කරේ කොහොමද කියලා බලන්න ඕන. හරි. මොකද මම මේක මෙච්චර questions කරන්නේ ආයි නෑ කිසිම විදියකින් ඔයගොල්ලන්ට වරදින්න නැති වෙන්න exam එකේදී. හරිද? මේ questions ටික කරනවා නම් මෙතන දැන් මම මේ තියෙන questions වලට අමතරව ටියුට් එකේ තියෙන questions 100ක් විතර ඊට පස්සේ past papers ටික කරනවා. එතකොට අනිවාර්යෙන් ඕගොල්ලන්ට ඇත්තටම හරියට ගන්න එක්කෙනට අර කිසිම විදියකින් වරදින විදියක් නැහැ. ඒ තරම් questions ටික අපි කරනවා. හරිද? ඒක නිසා තමයි මම කියන්නේ මට ඔක අප්ලෝඩ් කරන්න මට ඕගොල්ලෝ කරන විදිය මට බලන්න ඕන. මට අන්න ඒකනේ මට ඔක පේන්නේ නැති එකම දේ ඕකනේ. හරිද? ඔන්ලයින් ක්ලාස් එකක තියෙන මට පේන්නේ නැති එකම දේ ඒක. ඒ කියන්නේ ඕගොල්ලෝ කරනවා මට පේන්නේ නැහැ. ඒක නිසා ඕගොල්ලන්ගේ මිස්ටේක්ස් තියෙනවා නම් මට එවලෙම මේක හදන්න කරපු විදිය අප්ලෝඩ් කරන්න. කරපු විදිය අප්ලෝඩ් කරන්න. දැන් ඩිස්කෂන් ගෲප් එක අපේ ටියුට් අප්ලෝඩින් ගෲප් එක තියෙනවා. ටියුට් අප්ලෝඩින් ගෲප් එකට ඕගොල්ලෝ අද කරපු questions 22 එකයි දැන් මේ homework දීපු questions 8යි අප්ලෝඩ් කරන්න. හරි? ඉස්සරහ තව homework එනවා. හරි? ඕකේ. ඊළඟට තව ක්ලාස් මම අරක මේ පෝස්ට් කරා පුතේ ඔයගොල්ලන්ගේ ටියුට්ස් එක ප්‍රොන්ට් එකෙන් පෝස්ට් කරේ ප්‍රොන්ට් එකේ කියපු විදිහට මේ වෙන්ස්ඩේ ඔයගොල්ලන්ට හම්බ වෙයි ඊට. හරි වෙන්ස්ඩේ එනවා කියලා කිව්වේ. ඔයගොල්ලෝ දැන් මේ WhatsApp group එකේ ඉන්න මම නම්බර එකම තමයි දැම්මේ. ඒක නිසා ඒ නම්බර එකට තමයි කෝල් එකක් ආවොත් ඔයගොල්ලන්ට කෝල් එකක් එන්නේ. ඒක data sim එකක් නම් වෙන නම්බරයක් තියෙනවා නම් voice sim එකක් විදිහට මට පොඩ්ඩක් ඒක ඉන්ෆෝම් කරන්න මම එහෙම ප්‍රොන්ට් එකකින් ඉන්ෆෝම් කරන්න. හරි? කිපු විදියට බදාද තමයි එන්නේ. ඒක නිසා බදාද ඔයගොල්ලන්ට කෝල් එකක් එයි. ඕගොල්ලෝ දීලා තියෙන නම්බර්ස් එක් නම්බර් වලට. හරිද? ඒ නිසා වෙන්ස්ඩේ කෝල් එකක් ආවොත් ඒකෙන් ආන්සර් කරන්න මේ ප්‍රොන්ට් එකකින් ඔයගොල්ලන්ට එයි. මේ ඕගොල්ලන්ගේ මේ WhatsApp නම්බරයට අමතරව වෙන නම්බරයක් ඔයගොල්ලන්ට දෙන්න තියෙනවා නම් voice නම්බරයක් මේ විශේෂයෙන් මේක data sim තියෙන කට්ටිය වෙන්නත් පුළුවන්. voice number එකක් තියෙනවා මට පොඩ්ඩක් ඒක එවන්න මම එහෙමොත් ඒක ප්‍රොන්ට් එකට දෙන්න. හරි? ඒ අරෙන් මම දීලා තියෙන්නේ දැන්ට ඔයගොල්ලෝ මාත් එක්ක ඔය මේ group එකේ ඉන්න නම්බරේ තමයි මම දීලා තියෙන්නේ. හරි? හොඳයි. ඒක වෙන්ස්ඩේ එනවා. හරි. හොඳයි. Okay. Do you have any question up to this section? Do you have any question? Do you have any question up to this section? Because now we are going to move another section. Or do you understand this one? Do you understand this one? Oh, very good. Okay. Shall we move to?
Yes, sir.
Okay, very good, Puta. Shall we move to other section? That is dimension analysis. Dimension analysis. So, write a main topic. Dimension analysis. Dimension analysis within bracket applications. Okay, applications. Now we are going to discuss about applications of dimension analysis. Applications of dimension analysis. Actually, we can use dimension analysis to determine several applications. So because dimension analysis, we can use dimension analysis to determine the dimension of unknown physical quantity in an equation and determine the accuracy of an equation. Then we can use dimension analysis to determine a SI unit of a derived physical quantity, or we can use it to convert SI unit to a suitable another scale. That's mean millimeter to centimeter or meter to kilogram. We can convert SI units to a suitable scales using dimensions. So that kind of applications we have discussed. Okay. Okay. First, we should discuss about how to determine the accuracy of an equation using dimension analysis. So our subtopic is determining the accuracy of an equation. Determining the accuracy of an equation. Okay. Actually, suppose there's an equation. Suppose there's an equation. Suppose A equal B. If there is an equation like this, A equal B, that means left hand side is equal to the right hand side. If there is an equation, that means Puta, the left hand side quantity should be equal to the right hand side quantity. That means the left hand side physical quantity should be same as the right hand side physical quantity. Okay. Actually, we cannot equal length into time. We cannot equal length into mass. We cannot equal length into area. We cannot equal to area into volume. No. So if there is an equation, that means that if there's a equal sign, that means this one should be equal to this one. This one should be equal to this one. That means both should have same dimension. Both should have same dimension. So if an equation is correct, that means the dimension of left hand side should be equal to the dimension of right hand side. Do you understand? Okay. Okay. Suppose we are given an equation. And we are asked to find whether that equation is correct or not. Okay. Suppose we are given an equation and we are asked to find whether that equation is correct or not. Then we can use dimension analysis. And we can find the dimension of left hand side. And we can find the dimension of right hand side too. Okay. If both sides have same dimension, we can conclude that equation is dimensionally correct. Okay. That means this equation is dimensionally correct. Suppose we are given an equation, something like this. F equal ma square. We know this is wrong, no? Definitely we know this is wrong because we know the equation. F should be equal to MA. But suppose we are given F equal MA square equation, and we are asked to find whether this equation is correct or not. In such cases, we should determine the dimension of LHS. LHS means puta left hand side. So in an equation, there are two sides. What are those? Left hand side. Left hand side. Normally we use LHS to represent that left hand side. Then this is right hand side. Normally we use RHS to represent right hand side. Okay. Suppose we are given F equal MA square, and we are asked to determine whether this equation is correct or not. If it is correct, okay, understand my logic. If this equation is correct, the dimension of LHS should be equal to the dimension of RHS, no? Understand my logic, Puta. If this equation is correct, the physical quantity which is represented by left hand side should be the same physical quantity which is represented by the right hand side. So the dimension of LHS should be equal to the dimension of RHS. So in such cases, we are going to determine the dimension of LHS. The dimension of LHS is equal to dimension of force. So dimension of force, now we knew the dimension of force. What is that? That is equal to MLT minus 2, dimension of force. Okay. That is one. Then we can determine the dimension of RHS. That is equal to the dimension of M into dimension of A squared. Dimension of mass is equal to capital M. Dimension of M is LT minus 2 is squared. So if I simplify this one, I will have L into 2. L into 2 means L is squared. T minus 2. Minus 2 into 2 means minus 4. T minus 4. From the equation 1 and equation 2, it is very clear. The dimension of RHS is not equal to the dimension of left hand side. That means the physical quantity which is represented by LHS is not equal to the physical quantity which is represented by RHS. In such cases, we can say this equation is dimensionally incorrect. This equation is incorrect. Okay. Do you understand? That is the way to determine the accuracy of an equation. Okay. If you are asked to find the accuracy of an equation, you should take the dimension of LHS and RHS and determine whether those are same or not. If they are same, then we can say this equation is dimensionally correct. Dimensionally correct. Then, if they are not same, then we can say this equation is incorrect. Incorrect. Okay. Do you understand? Everyone? Do you want any further clarification? Okay. Others? Do you understand? Okay. Very good. Okay. Then our main topic is dimension analysis within bracket applications. First application is determine the accuracy of an equation. Determine the accuracy of an equation. Okay. You can write this one. It is about equation. Equation. A equal B. A means left hand side. B means right hand side. LHS and RHS, because after that I am going to represent left hand side by LHS and right hand side by RHS. Okay. Like this one. Okay. Okay, before writing anything, there's another thing. There is another thing, Puta. Suppose there is a equation something like this. There is an equation C plus D, something like this. A plus B and C plus D. Okay. You know, I think before I discuss about this, if there is addition, if there is an addition or subtraction, definitely two physical quantities should have same dimension. Suppose you want to add time. If you want to add time, you cannot add time to a mass. No, you cannot add time to a mass. Time is measured by second, mass is measured by kilogram. You cannot add seconds to kilogram. No, you cannot do that. You cannot add time to mass. You cannot add kilogram to liter. No, you cannot add Puta. So if there is an addition, of subtraction, definitely both physical quantities should have same dimension. Okay. Accordingly, if there is an equation, each term should have same dimension. That means dimension of A should be equal to dimension of B, and it is equal to dimension of C, and it is equal to dimension of D. If there is an equation, each and every term should have same dimension. That's mean dimension of A should be equal to dimension of B, that should be equal to dimension of C and dimension of D. Okay. Do you understand this one? Because we cannot add different physical quantities puta. Simply we can say we cannot add time to time to mass, no? We cannot add time to liquid, time to liters. Okay. Therefore, if there is an equation, each and every terms should have same dimension. Okay. Suppose we are given this kind of equation. AB plus C D equal PQ over R minus Z P. Now Z T. Something like this. If we are given, shall I erase this one? Shall I erase this one? Have note down. Shall I erase this one? This equation? Okay. Others? Others? Shall I erase
So
this
do
one?
we have to write that F equals MA square thing,
Sorry?
Asha?
Sorry, Buta?
Do we have to write this F equals MA square thing
This one?
that you've written below the one you've written below? Yeah.
This one?
Yeah.
No. It still you have to write this one only. This one only this one. A equal B. A equal B, and note down this one. Left hand side there, right hand side. Only this one. Don't write others. Okay. You have to write this one. This highlighted one. Okay. Don't write this one. Write only this one. A equal B. A equal B. A means left hand side. B means right hand side. That is only. Okay, Buddha. All right. Okay. If we are given this kind of expression, if we are given this kind of equation, according to our previous logic, each and every term should have same dimension. What is our logic? Each and every term should have same dimension, Puta. Now you have to determine what are the terms in this expression. So what are the terms, Puta? What are the terms in this equation? Tell me. What are the terms? In this equation, AB is a term. It is a term. This is a single term, Puta. Then CD is a single term. It is a single term. And PQ over R, it is a single term. And ZT, it is a term. Okay. In this equation, there are 4 terms. What are those? AB and CD and PQ over R and ZT. Those are the terms. Okay. Terms. According to our previous logic, each and every terms should have same dimension. That means AB, the dimension of AB should be equal to dimension of CD. That is equal to dimension of PQ over R, and that is equal to dimension of ZT. Okay, then we can write dimension of AB should be equal to the dimension of CD. That is equal dimension of PQ over R and dimension of ZT. Do you understand this one? Very important thing. Very, very important thing. Do you understand what I did here? Everyone, tell me. If you don't understand, I will explain that again. Okay. If you are given an equation, Puta, listen again. If you are given an equation, you should determine what are the terms within that equation. What are the terms? Terms are connected with plus or minus signs. Terms are connected using a plus or minus signs. Okay. So in this case, there are 4 terms. AB is a one term, CD is another term, PQOR is another term, and ZT is another term. So terms are connected with plus or minus signs. Okay. Okay, Buddha. Okay. Up to this, you can understand. No? Up to this, you can understand. No? Because we cannot add or subtract different physical quantities. Simply we can understand that one using this example. We cannot add time to kilogram. No, we cannot add time to a mass. No, we cannot add. No, suppose I have 5 kg sugar. I have 5 kg sugar. Can you add 5 seconds to that sugar? Can you add? We cannot add. That is meaningless. No, we cannot add 5 seconds to 5 kilogram sugar. No, those are different physical quantities. No, kilogram mass is a different physical quantity. Time is another different physical quantity. So we cannot add or subtract 2 different physical quantities. Okay, but we can multiply or divide. Okay, that can be done. Division or multiplication can be done within different physical quantities, but addition or subtraction cannot be done between 2 different physical quantities. Okay, the easiest example is we cannot add 5 seconds to 5 kilogram sugar. No, we cannot add. Okay. According to that logic, if there is an equation something like this, A plus B means 2 physical quantities are connected with plus sign. C plus D, that means 2 physical quantities connected with plus sign. If they are connected with plus sign, both should have same dimension. A equal dimension of A equal dimension of B. Dimension of A equal dimension of B. Then dimension of C should be equal dimension of D. As it is an equation, dimension of every term should be equal. Okay. Yes, Puta. This may be a length into time, because we can multiply 2 different physical quantities. You know, in our previous examples, we have determined the dimension of impulse. Dimension of impulse is equal to force into time. Force into time. Impulse is equal to force into time. That means force is a different physical quantity, time is a different physical quantity. The product of these 2 physical quantities are another physical quantity. Okay. Then we have determined the velocity. Velocity means length over time. Length means different physical quantity. Time is another different physical quantity. Okay, I will explain that one. So division and multiplication. We can do division and multiplication in between two different physical quantities. Okay. But addition or subtraction can be done among same physical quantities. Okay. Simply you can understand that thing. Can you add 5 seconds to 5 kilogram sugar? Can you add? You cannot add. No, you cannot add. Can you subtract 5 seconds from 5 kilograms sugar? Can you subtract? That's the thing. That is the thing, Puta. We cannot subtract or we cannot add two different physical quantities. Okay, two different physical quantities. According to that theory, if there are physical quantities, combined, which are combined with plus or minus signs, the dimension of those physical quantities should be same. Okay. According to that, A plus B equal to C plus D. So dimension of A should be equal to dimension of B, that is equal to dimension of C and dimension of D. Okay. Then this one. If we are given this kind of expression AB plus CD PQ over R minus ZT, then first thing we have to determine what are the terms inside this equation. Terms means those are the things which are connected with plus or minus signs. So first you should identify these signs. Okay. Terms means those are connected with plus and minus signs, plus or minus signs. So in this case, AB is connected with CD with this sign. So AB is a term and CD is another term. AB is a term and CB is another term. Okay. Suppose AB is a physical quantity. And CD is another physical quantity. And those two physical quantities are connected with this plus sign. That means AB, dimension of AB should same the dimension of CD. Do you understand that one? Still not? Still? In this case, AB is added to CD. No? In this case, AB is the physical quantity which is added to CD. No? AB is the physical quantity which is added to CD. So those are the two physical quantities connecting through a plus sign. So the dimension of AB means the physical quantity represented by AB should be same as the physical quantity which is represented by CD. Do you understand it too?
Okay, sir.
Okay. So in this case, there are four terms because there are two plus and minus signs. That means there are four terms. Okay. So 4 terms and equal sign means left hand side is equal to right hand side. If they are equal, definitely dimension of AB should be equal to dimension of CD and dimension of PQ over R and dimension of ZT. Everyone should be equal. Okay. Then do you want another clarification? Is still not. මට කට්ටියගේ morning respond එක. Do you
Understood,
understand?
sir.
Huh? Good. Others? Okay, very good, very good, very good. Okay. Okay. Right under that sentence, right under that equation. There are two sides. There are two sides in an equation. There are two sides in an equation. If it is an equation, if it is an equation, if it is an equation, the physical quantity, the physical quantity the physical quantity in LHS, in LHS, should be same, should be same, should be same, should be same as the physical quantity in RHS. Should be same as the physical quantity in RHS. Therefore, the dimension of LHS, dimension of LHS should be equal to the dimension of RHS. In another paragraph, so if we are given an equation, to determine its accuracy, we should determine the dimensions of LHS and RHS separately. LHS and RHS separately. If they are equal, if they are equal, the equation is dimensionally correct. The equation is dimensionally correct. If they are not equal, the equation is incorrect. The equation is incorrect. Okay. Okay. Next question. Now, next topic. Next topic is factors to determine factors to be considered. Factors to be considered. Factors to be considered. Factors to be considered in this study. In this study. Okay. Suppose we are given, okay, write this one. Okay, Buddha. Listen to me. Suppose now we are given an equation. Suppose now we are given an equation. And we are asked to determine whether it is right or not. Whether it is right or not. In this analysis, first you should understand this one. First, you should understand this one. If there is an equation, and in this equation, if there are several terms, in this equation, every terms should have same dimension. Every terms should have same dimension because we can add or subtract same physical quantities. Okay, we can add or subtract same physical quantities. So each and every terms in an equation should have same dimension. Okay, that thing you should understand when you are determining the accuracy of an equation. Okay. Do you understand this one, Pute? Do you understand this factor? Okay. Okay. Write this one, Puta. Under this topic, write this one. Addition or subtraction can be done between same physical quantities. Suppose there's a 5 kg sugar bag. Can you add 5 seconds here? Can you add? I cannot add 5 seconds. No, I cannot add. This cannot be done. Okay, this cannot be done. We cannot add 5 seconds to 5 kg sugar. No, so we cannot add or subtract, and we cannot subtract 5 seconds. No, from here we cannot do this. We cannot add or subtract. Two different physical quantities. Okay, so we cannot add or subtract. Cannot add or subtract two different physical quantities. You can write this example too. Actual temperature, we can define it as theta. Theta. Dimension of temperature is as theta, but in A levels, we are not going to use that one. But if we are given in this in the dimension in a question, then only we can use that one. Otherwise, we don't want to remember that one. Okay. In A levels, we are going to use M, L, and T only. But if we are given the temperature, dimension of temperature as theta and dimension of current as I, then we can use them. But otherwise, we are not going to use them. Okay. Okay, Victor. If you have, if you have, if you have a question, if you have a question regarding temperature and current, then you can use the dimension of temperature as theta and dimension of current as I. Dimension of temperature as theta and dimension of current as I. Okay. Okay. What about this? Have you done this one? Okay. Right under this, right under this. Right under this. That means the dimensions of each and every terms, the dimensions of each and every terms the dimensions of each and every terms in an equation should be equal. Should be equal. මේක කොටු කරගන්න. Dimensions of each and every terms in an equation should be equal. This is very important theory. This is a very important theory. Okay. So examples. This is example 1 and this is example 2. This is example 1 and this is example 2, Puta. In the if you are given an equation, first you have to identify the terms. Terms are connected with plus or minus signs, plus or minus signs. So in this case, A is a term, B is a term, C is a term, and D is a term. Okay, according to this theory, the dimension of A should be equal to dimension of B, and it should be equal to dimension of C, and it should be equal to dimension of D. Those are the terms. Those are the terms. Those are the terms. We can write this one. Terms. Okay. So the dimension of A and dimension of B and dimension of C and dimension of D should be equal to each other. Okay. Then in this case, we have to determine dimension. Dimensions are, sorry, we have to determine the terms first. Terms are connected with plus or minus signs. Then there are two plus and minus signs. So those are the terms in this equation. Those are the terms in this equation. Those are the terms in this equation. Okay. Once you write down this one, please let me know. Please let me know. No. If you complete writing, please let me know. In here, you can write this one also. Terms. Terms. Those are the terms in this equation. Terms. Okay. Okay. Once you complete this one, please give me a thumb. Good. Others? Good. Others? Okay, Buddha. Listen to me. Okay. Suppose we are given two kind of equations. Two kind of equations, and we are asked to determine whether they are correct or not. First one, if equal three kind of equations. So if equal ma square, this one. Second thing, if equal ma. Third one, if equal half ma. Half ma. Now we are given three kind of equation. Okay. Actually, I have taken f equal ma because we know this equation. We know this one is the correct one. Okay. Both are incorrect equations. Okay. All right. We know this equation. That's why I choose this one. Okay. Let's determine whether the equation is correct or not. So if we want to determine the equation is correct or not, first we should take the dimension of LHS and RHS separately. And okay, first we are going to take dimensions of LHS and RHS separately. Dimensions of LHS. It is equal to dimensions of force. Dimension of force. So dimension of force means it is equal MLT minus 2. That is equation number 1. Then dimension of RHS. Dimension of RHS. Dimension of RHS equal dimension of M into dimension of A squared. Dimension of A squared. Dimension of M is, it is a mass, Puta, and A is acceleration, so it is dimension of A is equal LT minus 2 squared. So in here, L into 2 means L squared, minus 2 into 2. Minus 2 into 2 means minus 4. Minus 4. That is equation number 2. That is equation number 2. So from equation number 1 and equation number 2, definitely we can say this equation is incorrect one. This equation is incorrect one because the dimension of L is not equal to the dimension of, so dimension of LHS is not equal to dimension of RHS. Okay. Dimension of LHS is not equal to the RHS. Then we can say dimension of LHS. dimension of LHS unequal the dimension of RHS. Therefore, this equation is incorrect. Is incorrect. This equation is incorrect. Do you understand what I have done this? What I have done here? Do you understand this one? This calculation? Everyone, give me a thumb. If you understood, please give me a thumb. Good, good, good. The second one. The second one. If you want to determine whether it is correct or not, first we should get the dimension of LHS. Dimension of LHS equal dimension of force, that is equal MLT minus 2. MLT minus 2. Then dimension, that is equation 1. Then dimension of RHS. Dimension of RHS equal dimension of M into dimension of A. That is also equal MLT minus 2. MLT minus 2. From equation number 1 and from equation number 2, we can say both have same dimension. Both LHS and RHS have same dimension. So this equation is correct or not? Correct or not? Everyone, correct or not?
Correct.
Others?
Correct.
Correct. That's the problem. We can only say this equation is dimensionally correct. We cannot say, Buddha, this is correct or not. So we cannot say this is correct. If it is wrong, definitely we can say it is wrong. If it is wrong, definitely we can say this is wrong. But if we have two similar dimensions here, we can only say dimensionally, this equation is dimensionally correct. Dimensionally correct. Okay, I will explain what is the reason for this. Okay, this equation is dimensionally correct, Puta. Okay, dimensionally correct, but I do not know whether it is correct or not. Only I can say this is dimensionally correct. I will explain what is the reason for this one. So dimension of RHS equal dimension of LHS. From this, we can only say this equation is dimensionally correct. Dimensionally correct. Dimensionally correct. Okay. Okay. What is the reason for this one? Why I cannot directly say it is correct? Why I cannot say that one? The reason is here. The reason is here. Okay. If we are given this kind of equation, shall we check whether it is correct or not? Shall we check? Dimension of LHS. Dimension of LHS is equal dimension of force. So it is equal MLT minus 2. Dimension of RHS. Take the dimension of RHS. Dimension of RHS. Take the dimension of RHS. Please tell me, what is the dimension of RHS? What is the dimension of RHS, Puta? Huh? MLT minus 2. As I said earlier, half is a number. Half is a number only. So number doesn't have a dimension. Number doesn't have a dimension. Numbers do not have dimensions, Puta. So half doesn't have a dimension. So that is equal to the dimension of M into dimension of A. Within the bracket, we can say half is a number, half is a number. So it does not have a dimension. It does not have a dimension. Then dimension of RHS. Dimension of RHS is equal to the dimension of M and dimension of A. And it is equal MLT minus 2. What is that thing? In this case, dimension of RHS also equal to the dimension of LHS. Dimension of RHS also equal to dimension of LHS. Is this equation correct? Is this equation correct? Is this equation correct? No, we know this equation is not correct. No, actually we know this equation. No, so this equation is not correct. But this equation is dimensionally correct, Puta. Dimensionally correct, no? Dimension of LHS equal dimension of RHS. Dimension of LHS equal dimension of RHS. So this equation is dimensionally correct, and we cannot say whether it is correct or not. Okay. So that is a limitation of this analysis. That is the limitation of this analysis. If the equation is wrong, obviously we can say it is wrong. There's no any further arguments. We can directly say that is wrong. But if we have same dimensions in RHS and LHS, we cannot say whether the equation is right or not. We can only say the equation is dimensionally correct. That should be our statement. That should be our statement. This equation is dimensionally correct, Puta. Dimensionally correct. And we cannot say whether it is correct or not. But it is dimensionally correct. Did you understand what I'm saying? Everyone? Do you understand, Puta? Huh? Good. This is, so in this case, this equation is dimensionally correct. Dimensionally correct. Dimensionally correct. This equation is dimensionally correct. Those are the three states. Those are the three states in analyzing equations. Okay. If the equation is incorrect, that means the dimension of RHS is not equal to the dimension of LHS. Definitely, the dimension is incorrect. Definitely, the dimension is incorrect. So, we can say this dimension is incorrect. But if we have same dimension in RHS and LHS of an equation, we cannot say whether that equation is correct or not. But we can say this equation is dimensionally correct. That means the dimension of LHS and dimension of RHS are equal. So this equation is dimensionally correct. Okay. So this is the limitation of this analysis. Okay. We can only distinguish whether the equation is when the equation is wrong. When the equation is wrong, we can distinguish that thing. But if we have same dimension as LHS and RHS, we cannot determine whether the equation is correct or not. Okay. Okay. You can note down this thing. You can note down this thing. Once you note down the equation in the board, please let me know. Please give me a thumb. Very good. Others? Once you complete, please give me a thumb. Good. Others? Good. Others? No, Buddha. Actually, what I wanted to say is, we know if should be equal to MA, no? F should be equal to MA. Therefore, this is the correct equation. This is the correct equation, and this equation is incorrect. We know this equation is incorrect. But once I did the dimensional analysis, the dimension of LHS was equal to dimension of RHS. Dimensions of LHS was equal to dimension of RHS. In both two cases, dimension of LHS and dimensions of RHS are equal. So when we are calculating, suppose the dimension of RHS is equal to dimension of LHS. If we find the dimension of LHS is equal to dimension of RHS, then we cannot say this equation is correct. That is the thing I wanted to explain. That's why I took two different equations. This is the correct equation and this is the incorrect equation. We know this is incorrect. Okay. But both cases we have LHS and RHS. In both cases, the dimension of LHS and dimension of RHS are equal. Okay. So when we are doing calculation, and we find the dimension of LHS and dimension of RHS are equal, we cannot say this equation is correct. We can only say this equation is dimensionally correct. This equation is dimensionally correct, but I don't know whether it is correct or not. This equation is dimensionally correct. But when we are calculating, if we got the different dimensions in LHS and RHS, definitely we can say this equation is incorrect. That is the thing. In this case, LHS and RHS dimensions are unequal. So in this case, definitely we can say it is wrong. But if we have same dimension with both LHS and RHS, we cannot say whether it is correct or not. That is the thing. Do you understand? Steve, do you understand?
So that means we can say that it's only dimensionally correct.
Yeah, it
Not
is
the
dimensionally
equation is
correct. That's why I wrote this one, dimensionally correct. This is statement. When you are calculating, when we are doing analyzing, don't say this equation is correct, because you cannot determine that one. Okay, you cannot distinguish a correct equation. You cannot distinguish a correct equation, but you can distinguish an incorrect equation. You can distinguish this one, but you cannot determine an correct equation. Okay, you can only say this equation is dimensionally correct, and I don't know whether it is correct or not. So that is a limitation of this analysis. That is a limitation. We cannot go beyond that. Okay, we cannot go beyond that through this analysis. Okay, so that is a limitation. Understand this one? Others? Do you understand this one, Puta? Good. Others? Steve?
Okay, sir.
Okay. 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 Right under this, right under this. According to above examples, if the dimension of LHS, if the dimension of LHS, if the dimension of LHS is not equal to the dimension of RHS. Dimension of RHS. The equation is incorrect. The equation is incorrect. The equation is incorrect. Incorrect. But if the dimension of LHS equal dimension of RHS, if the dimension of LHS, if the dimension of LHS is equal dimension of RHS, the equation can be correct one or incorrect one. Can be a correct one. Can be a correct one or an incorrect one. Can be a correct or incorrect one. But dimensionally it is correct. Dimensionally it is correct. Dimensionally it is correct. Dimensionally it is correct. So in another paragraph, so in this analysis, we can distinguish an incorrect equation, but we cannot distinguish a correct equation. We cannot distinguish a correct equation. That is a limitation of this analysis. That is a limitation of this analysis. That is a limitation of this analysis. Okay. Okay, what about today's lesson? Did you understood that one? Did you understand this one? Good. Others? Good. Good. Very good. Okay, Buddha. Then we will have another lesson, another extra class on Tuesday evening, 3 to 6. In that class, we can discuss how to determine, how to do calculations in this theory, and we will learn the second application of dimension analysis. Those are the things we are going to study on Tuesday class. Okay. Okay. Then after 6. Okay. Then I will give my free times to you. Yes, definitely. That other thing, you should upload your answers to tutor uploading group. Okay. Okay, then I will give you my free times. Please let me know what are the most appropriate time for you. Then I will choose a time. Okay. I think that thing is better. I will give my free times. Okay. Yes, I can do after 6, Puta. I can do after 6. But others should I have to get the consent of others. Okay. Then I will ask through your group. Please let me know. Okay. Okay, Puta. Have a nice day. We can complete this class now by now. Okay.
Thank you, sir. God bless you.
Okay, you're welcome. Thank you, Puta.